36 days to 36. Now you got to come in knowing some stuff, right? You can't just come in not knowing any math, but if you're solid in algebra, what's up, tonight? Come on in. If you're solid in algebra 2, this guy can get you to a 36. You gonna sit over there?
Where? Over there.
No, take the mix.
There you go.
Yeah. This guy can get you to a 36 on the ACT. He's been working with my kids, making ridiculous growth. They love working with him. He teaches history. Why he's teaching math? He's obsessed with math. So that's why I wanted to introduce you guys to him, because I like teachers who are obsessed with what they teach, because I know those results are going to be great. So with no further ado, I'm going to go ahead and share his slides, and he's going to talk about his. Which one is yours? Going to talk about his program, his approach to math, and how he gets the results that he gets, and we're going to do it so that we can end up with like 35, 36s on the ACT. All right, so that's enough of me talking. All right, Amos, go ahead. Here you go. Let me fill up. Let me know if you need anything. You right here.
No problem. I'm right here. Okay.
Yeah, the camera's on you. Huh? You put it in one.
If you need to move this, no problem.
Yep. You got it in one. Amos, you get Amos a beautiful camera. Give me a second.
No worries. And then this is gonna show up clear.
Yeah.
Okay. So just look on that and that. Okay. And thanks to everybody who came out and those online. Look forward to doing some math together with you today. And there should be some, I think, some parents. Thank you, Dr. Hakim, again for coming. And then the parents on the call, thank you for joining us.
Thank you. This is for.
In case you need the bag.
Yeah. You got the camera on? Mm-hmm. Yeah, I guess you do. That's a crazy question. Just record it, and we'll do it.
So it don't go. You can put it in two instead?
Asian minds is not coming out, apparently, from the camera. So just record it, and we'll share it later. Okay. I not want to lose time with him teaching.
Yeah.
Time. Yeah.
I'm gonna let him sit down and make sure it's.
Okay. Can we, you guys can all hear me all right?
The mic.
Do you have, yeah, whenever you have the mic, let me know if you guys see the, oh, this is my mic, but. Okay.
Oh, so you're gonna just use that one?
Yeah, but do you have one too?
Huh?
Yeah.
I'm saying, hey, audio going to the camera. You want him to...
Yeah, sure.
Yeah, audio going to the camera for me.
No, I'm saying, was...
Oh, okay, sure.
Yeah, I'm saying I got a mic going into the camera.
Oh, yeah.
Yeah.
Can I, where would you like
that's
this?
your mic.
No, this is mine actually.
Oh, okay. Amos is a videographer too.
Yeah, so would you like it?
You're like, hold on, let me have it all.
Would you like it this way?
No.
Sorry, we're just doing a final setup. Just let me know what you want. Okay. And then I'll send you this one too if you have any issues with it. Okay, perfect. Let's just turn that around. Okay. So if everybody has a pen and paper, please something to write with. And for parents, this can be a great review for you. Maybe you haven't done some trigonometry in a while. I promise I'll keep it engaging, straightforward, and maybe it'll help with your day job too. Because the thing about math, I'll just say this about math, and then we'll get started with the slides. So I'm going to be working through about 10 math problems. We'll do more at the end, but I wanted to give parents a chance, or students, to ask any questions. But the thing about mathematics is that mathematics sharpens the mind. It's not always, like when you learn math, you could think of it like what it does to you outside of its own application. So let me give you an example of this. Have you guys, some of you play sports, right? And if you think about it, how often do you actually use the skills from baseball when you're going just down the road? Like, let me give you an example. When you wake up and you go through your day and you're not playing baseball, You don't necessarily use the swing when you're walking down the street, right? But is it important that you learn to play baseball if you love baseball? Yes, but the reason you learn it is not because you're going to use it when you're just walking down the road. You learn it because it teaches you some other life skills, like teamwork. Does that make sense? So the point is not just the thing you're doing, it's what does it do to you as a person. Mathematics is like that. Have you guys ever learned a math topic and you're not sure, when am I ever going to use this? Have you ever had that happen? Anybody ever have that? Okay, when am I ever going to use this, right? When am I ever going to factor a polynomial? I tell people, if someone walks up to you and says, hey, can you factor my polynomial? You need to run away, because that's not a question you should be hearing on the street, right? It's kind of like a joke, but seriously, think about it. Who factors polynomials just every day? No, we don't do it. I'm a physicist by training. I don't factor polynomials every day, right? I'm a mathematician and physicist, but do I love factoring polynomials? Yes. Why? Not because I'm going to use it for anything. Why? Because it's beautiful. Do you see the point I'm trying to get at? It's just beautiful. Like when I factor polynomials and do rational expressions, sometimes I just want to cry because the problem is so beautiful. So I want you to think about math like that. Math is beautiful. That's number one. Everybody get that? Maybe you have a bad taste in your mouth. We're going to work to remove that. And I want you to just remember, math is beautiful. Okay. Now, this is the title of my talk. I'm going to give a quick 10-minute talk to tell you how to get a perfect score, okay, on the math portion. So we're going to take 10 minutes. I'm going to talk about the strategies for getting a perfect score. Everybody knows what a perfect score is? A perfect score is a 36 on the ACT. It's an 800 on the SAT. I can share with you how you can get a perfect score. But before I do that, let me tell you my experience with perfect scores. When I was in 5th grade in elementary school, we had to take an exam called the National Common Entrance Exam. I was in primary 5, we call it in Nigeria. And primary 5 and primary 6 students take this exam. That exam determines your life. Let me repeat for those at the back. That exam determines your life. How? Because if you fail that exam, you go to a bad secondary school. And if you go to a bad secondary school in Nigeria, you're not going to a good university and you're not going to become a doctor. Do you see my point? So that exam in primary 5 determined how my life would go in many ways, right? Because those who want to go to certain good universities in Nigeria have to get a very good score in their JAMB and in their WAEC. But how are you going to get a good score in your JAMB and your WAEC if your teachers are not good in your secondary school? So the point is, I'm not saying this is how it should be all over the world, but the point I'm trying to make though is I knew this exam was important, but I was already a nerd, so that was good. I was the top of my class at this time, and so in primary 5, I had to take the exam, and so I'm going to tell you my story with the exam. Oops, sorry, one second.
Where that noise comes from?
Just the fireplace.
Oh, we just have a fireplace on the TV.
What's going on? Okay. I'll figure it out.
So this is 1999, okay? 1999 in Lagos, Nigeria. I have a big test coming up. How did I study for the test? I took the textbook. It was called Ugo Si Ugo. That was the name of the book. I went through the textbook, and every time I got a problem wrong, I went back and found out why was I wrong. This was primary 5, Lagos, Nigeria. The results came out, and we thank God it was a good turnout. I was the best in the school, and the highest 6th grader was over 60 points below me. I was in 5th grade. I scored higher than all 6th graders, so I never did 6th grade. I went right into 7th grade. Now, the key thing is, most people who also went into 7th grade to the school I went to, they were also the best in their schools. Does that make sense? So I went into a high school where everybody was like the best in their school. Some of my classmates, I know some of them, like today, some of them are senior software engineers at Google. Some of them are Yale, graduate, PhD in biochemistry. These are some of the classmates I have, right? So I went to school with people, some of whom are senior software engineers. You know, if one of them becomes the CEO of Google today, I won't be surprised. Now, I'm one of the people I joke and say it's like I kind of went off track, right? But a lot of them stayed, they worked, whatever. Okay, but the point is, I was surrounded by people that were pursuing excellence in education, and it affected me, right? Because then, when I was hanging out with my friends, if I was failing, or if I was getting a 70%, I look around at my friends, I'm like, Amos, why are you being lazy, right? So who you surround yourself with is a key step to excellence. Does that make sense? Who you surround yourself to is very important. You look at some of the people who are running companies all across America right now, a lot of them are friends in university. A lot of them are friends. You need to remember, when you're around your friends, you always want to be challenging one another to do better. That's key. So that's my story. I scored the highest, using those tactics that I'm going to share with you today. But years later, before I came to America, I was sitting next to a young man next to me in the US Embassy in Nigeria, and we were both, checking our results after taking the SAT exam. And the young man next to me got a perfect score on his SAT. He went to Caltech. If you don't know anything about Caltech, it's like the MIT of the West, right? Caltech, Berkeley. He went to Caltech. He's also, I believe he's an engineer. I don't remember what branch, but he went to Caltech on a full scholarship. 100% paid off. 100%. No, he didn't pay anything. He came from Nigeria straight to Caltech, okay? But here's the interesting thing about this guy. He got a perfect score, but he didn't jump when he saw his result. So I asked him years later, why didn't you jump when you got your result and it was perfect scores? Because I practiced well. I knew, he knew. You know what I mean? When you practice and you know, you're like, yeah, what is it supposed to? And I said, what did you do? True story. And here's what he said he did. And I'll tell you, this is one of the strategies. This is worth the investment. He bought 3 different textbooks of practice of the SAT. I think it was Kaplan, Princeton Review, and Barron's, for example. And then he went through all the problems 3 times, back and forth. And if he finds any gaps, he fixes it. Did you hear that? 3 different publishers. Why did he use 3 different publishers? Because this is from another student. Now this is a student of mine that did the same thing. One of my students says, because we realize the more you use different kinds of textbooks, the more your brain gets to see different types of problems. Barron sometimes is a little more difficult, and then Princeton Review is a little different. Kaplan is different. So guess what you're doing to your mind? It's like you're playing against different teams, right? You're playing against the baseball teams here or here or here. You're getting experience. Does that make sense? So that no matter what kind of problem they throw at you, you're like, I got you. Like you're not worried. So this is the principle. I'm just going to say this and then we'll wrap up with the strategy side and we're going to do math. This is the principle I was using when I was in primary 5. I didn't know some of this, and this is the principle some of my friends have used through the years. So let's answer the question of what is the principle that is at work, right? I'm just going to pass this stool so that in case if somebody wants that stool and this one. So here's the principle at work. Are you guys ready for the name of the principle? It's called deliberate practice. Everybody have that down? Deliberate practice. Deliberate. I'm not the English ACT guy, right? But I just want to tell you I can spell. So anyways, I'm kidding. So deliberate practice. Everybody get that? Remember those words. They will literally change your education career. Deliberate practice. How do you get good at anything? That's what I want to answer in the first few minutes. The way you get good at anything is you have to learn to use the principle of deliberate practice. So here's the principle of deliberate practice. Give me 1 second. I'm going to slide to my next slide. Okay, so deliberate practice. Have anyone heard of 10,000 hour rule before? The 10,000 hour rule. Okay, who came up with that research? Who did the work about the 10,000 hour rule? Anybody know? Okay, his name was Anders Ericsson. Anders Ericsson did the research, and then Malcolm Gladwell talked about it in Outliers. But the man who actually did the research is Anders Ericsson. What did they do to get this rule called the 10,000 hour rule? They found out that if you take someone, give them 10,000 hours, you give them a coach, they will do amazing things if they have the right guidance and they get 10,000 hours and they get a lot of time. Does that make sense? So it's important that you learn what deliberate practice is, no matter what you want to do with your life, right? Okay, now let's talk about how it ties to this. So let's say I'm doing a math problem on the ACT, and actually Mr. Silas is going to help me get the pen, if you don't mind, Mr. Silas, and I'll do some problems with that. But let me give you guys a very practical example. Is everybody ready? What is 1 over 3 plus 1 over 5? What do you use to do that problem?
I try to make a common denominator.
You need a common denominator. Okay, I asked him what is 1 over 3 plus 1 over 5. He immediately thought about a common denominator, which is correct. It's what the thing is to do. He's decomposing the problem down to subtopics that can better help him tackle the topic in front of him. Okay, I'm a soccer player, so I play soccer, tennis, and ping pong. If I was to rank which one I could go to in the Olympics for, it's probably soccer. But let's go back to, so I'm just saying there's some sports you play, you're kind of ashamed to play when everybody's watching, right? But by God's grace with soccer, I'm not afraid, right? I play soccer, I won tournaments and all of that. But I'm also a ping pong player, right? That's another one I could probably compete, maybe get 100th place. But I could try. But soccer and ping pong, and I also play tennis. But the last sport I added to my list was basketball. I went on a mission trip one time in Minnesota, and they introduced me to some kids, and we were playing basketball, and they put me to shame. They were dribbling, I was all over. So I said, you know what, I'm coming back, and I'm going to be better. And guess what? Today, if you see me play basketball, you think I grew up playing basketball. No, I didn't. But here's what I had to learn in order to become good at basketball. What are the skills you need to know to be good at basketball? You need to know how to dribble, right? You need to know how to handle the ball, right? That's number one, okay? You need to know how to take free throws before you know how to shoot threes. Can you imagine if I just showed up and started shooting threes without knowing how to shoot free throws? Are you guys seeing the sequence I'm trying to describe? That sequence works for math. That's my point. If you break math down to smaller pieces and build, you will be good. I'm not saying you might. I said you will. But here I am. I just want to apologize on behalf of the whole math education system. Because we failed you. The math education system has failed you. Especially in America. And I apologize. Even me, I was a math teacher too. I apologize. Why? Because some of you couldn't shoot free throws and we told you to shoot threes. In what discipline do you ever allow a person to do more when they don't have a foundation? Tell me one discipline we ever do that in. Ever. None. Except math education. And we wonder why kids hate math. And here's my answer. Because if you taught any other skill the way we teach math, people would hate it. If I taught you music the way we teach math, you would hate it. Case in point, Paul Lockhart. There's a whole book about this. This is not just me. There's a whole book. It's called what? A Mathematician's Lament. And this guy says, we've ruined it. He's a mathematician. He's like, we've ruined the math education of a generation. We've literally ruined it. And why do I say, especially in America? And I promise I'll come back for my rant now. I'm just apologizing because I know some of you here are afraid of math. See what I'm trying to do? I'm trying to remove that fear from you because I'm trying to tell you it's not your fault. You don't have to be afraid anymore. From today going forward, when you see math, guess what you need to do? Say, I'm going to be deliberate. I'm going to understand what the subtopics are, and I'm going to win. Every math problem is like a battle. I'm going to win. And guys, I'm not a prodigy of the kind of some other people who are prodigies. Do you guys know what a prodigy is? Like they're doing calculus at the age of 4. I wasn't doing calculus at the age of 4, but I learned to practice and I loved to do what I was doing. And today I'm a physicist, but I could have missed the mark if I completely ruled myself out. I wasn't the best in math. The guy who's a senior software developer or a developer at Google, my friend, he was the best in math. For 6 years in a row, he went to MIT, 2 master's degrees. Cambridge University, he didn't want to go. He could have gone to Cambridge. This is one of my best friends. Like literally, if he became the CEO of Google tomorrow, I would not be surprised. I promise. And the reason is, I bring this up because he knew how to practice. So everybody please write the word deliberate practice. Everybody got it? Deliberate practice. Okay, so we're going to do some math problems. Sorry, it's been a long intro. But let me land the plane. Oh, sorry. Let me get you to the first problem we're doing right here.
Switch it to the sword.
Some people eat paper.
Okay, so everybody on Zoom, can you guys see the 7 topics? And then everybody who is in person, I'm just going to list 7 math topics, okay? So we're going to do 7 math topics. The first one is called prime factorization. Everybody get it? Prime factorization. Oh, I see it there. Perfect. Everybody see the first topic? It's called prime factorization. So that's the first topic. Guys, if you know how to prime factorize, like 30% of your life problems are gone. If you know how to prime factorize, 30% of your problems, I think. I'm just making up the percent, but it's a huge percent. Everybody get it? What's the key topic? Prime factorization. Why? Because prime factorization is the foundation for finding the lowest common multiple and the greatest common factor, which is the foundation for adding fractions, which is the foundation for doing algebra, which is the foundation for doing pre-calc. One topic is the foundation of literally almost everything else. Prime factorization. 28. What is the prime factorization of 28?
72.
Okay, but we're close. You're not. I need the prime numbers that make up.
Oh, 7,
2, 2, and 7.
2, 2, and 7, right? So 2, 2, and 7. So 2 times 2 times 7, right? We'll have a pen right here too, if you please pass it to the back.
No.
Oh, they need a pen. Okay, okay.
4.
Okay, perfect. So here you go. I got a pen. There's another pen here. So that leads me to another thing. Taking notes. Just taking notes, guys, is already a lot. And I know Amos is not here, so I'm not here to just bash the American math education, math. But here's my point, though. My heart hurts when I see kids struggle in math when it's not their fault. That hurts to see that. Because some kids come to do math and they want to try. They want to do well. But then the system fails them. Guys, I'm just going to keep it real. If you learn math in America, you're guaranteed to be about 2 to 3 years behind your global counterparts. I'm just going to keep it real. You're behind. America is behind, not you, but America. You know why I say that? Have you looked at what our counterparts are doing in Taiwan and Singapore and China and Japan and South Korea and Hong Kong? They graduate easily 2 years ahead of us. Here's why that's a problem. The world job market is no longer localized. You're going to apply for a job and your resume is in the same pool with somebody who went to school in Singapore. Who do you think they're going to pick if they're looking for somebody who knows math? I'm sorry, guys, America, we got to step it up. But here's the good news. 530 scholars, you've got the news. You got to raise the bar. And I want you to pull the whole city with you. Pull up the bar. Do you see my point? You guys have heard the news. Now you got to start demonstrating this. And I can give you what they're doing. Don't get me wrong. But get that perfect score on the math on the ACT and then keep growing in your math ability because math is the new gold. How many of you know that the current AI revolution is literally moving at the pace of math ability? They're waiting for a math breakthrough to actually move more into the AI world. I'm telling you what the CEO of the AI companies are saying. They're like, we just need a couple more math breakthroughs. So guess what that means? That means that the more people who know math, the more opportunities those people will have because when you ask AI a question, AI doesn't know English. It only knows math. So it actually takes your question and changes it to equations. That's all it knows. Everything AI is math. Why do you think people in Germany and Japan and China and America can use the same AI and be getting answers? Because it's converting everything to math. And math is a universal language. You can't not know math in the AI revolution. Everybody hear that? It's not an option. And I'll say one more thing, I promise. Math tech. Okay. Quantum computing is not even here yet. It's supposed to come in the next 5 years. But that's more math. And you guys see my point? The world in the next 5, 10, 15 years is literally going to be dependent on how good are you in math. So what I want from 530 scholars is we get that perfect score on math regularly. I want you guys having pizza parties on Friday and like, hey, we're just doing some math ACT problems. We're just doing math. Surround yourself with people who want excellence. That's the key. Have you guys ever seen someone who's pursuing excellence in a certain sport? Right? I mean, you guys have the iconic legend of any athlete, right, that has made a mark in that sport, of Michael Jordan, right? But that skill set he was showing, not all of us can do what he did, but we can do it in our own craft. And by God's grace, you know, for me, do you know what that means? I want to do math, so when you see me do math, you think I'm an artist. I want to do math, and when you see me do math, you're like, that guy's crazy, and I am crazy. Right? In a good way. Okay, anyways. So the first topic you need to know is what? Prime factorization. The second topic is factoring polynomials. You need to factor polynomials in your sleep. Like, guys, do you understand what I'm saying? You ask me to factor any polynomial, and it's like, it just needs to happen. So, what is factoring polynomials? The AC method, right? AC method. Two numbers that multiply to give AC and add to give B. Everybody get that? Just write it down, I'll explain. The AC method. Guys, if you know prime factorization and you know how to factor polynomials, oh, you're close. You're already close. And then you add the rules of exponents. Oh, you're getting close now. That's number 3. Rules of exponents. How do exponents behave? And while you learn the rules of exponents, can you please also learn the rules of radicals? So learn the rules of exponents, the rules of radicals, and the rules of logarithms. Logarithms. Everybody hear that word? That's a big word. Logarithms. I'll tell you a quick story about logarithms. Logarithms was not discovered by a professional mathematician of the kind that we talk about. It wasn't discovered by Isaac Newton. It wasn't discovered by a guy named Euler or Gauss. I tell people, how can we teach mathematics and not tell people who some of the greatest mathematicians are, or some of the history of mathematics. If you wanted to start learning how to play basketball right now, wouldn't we tell you, you need to know Michael Jordan, you need to know Stephen Curry, you need to know Klay Thompson? I'm kidding. I know some of you have issues with Klay Thompson. But anyways, you need to know Klay Thompson, right? You need to know those names. Why? So you can aspire to be like them. But we go to math class and kids don't have a clue who to aspire to be like. How does that make sense, right? And I know I feel like guys, the good news is this. I'm not just going to tell you the bad news and not tell you the good news. But I'm just trying to tell you the bad news. The bad news is that the system is not getting you where you need to go. And I need you to take some ownership, and you got to go. Go. You don't need permission anymore. Just go. Go as far as you can and go in your math journey. Number 4, as we discussed, we've looked at the first 3. We've talked about the 4th one, which is radicals and logarithms. And the mathematician responsible for logarithms, his name was John Napier. And John Napier, oops, sorry, I clicked on the wrong one. Let me go back to my slides. Let's see. How do I do?
Command tab.
Command tab.
Let it go.
Okay, I'll let you do it. Sorry. Okay, so John Napier was from. Anyone know John Napier? Name ring a bell? Okay, well, you're going to leave here knowing that. John Napier was a Scottish mathematician, and he literally was trying to find ways of doing calculations. And part of why this was important is, guys, do you remember back in the day when you left your country sometimes? You're like, I think I'm going over there. Like, I think I'm going there. Okay, we'll see if I get there. That was literally like, we're not sure if the ship is going to get there or there. Can you imagine a life like that? Can you imagine living in the 1400s? You guys think life is hard? Because, some of you, Chick-fil-A is closed on Sunday, you think life is hard, Or some of you go to McDonald's and they don't have your favorite sandwich. Come on. Can we all admit that we've become lazy as a society? Can we agree? Okay, and then let's repent. Okay, the point I'm trying to make is this. John Napier's calculations help the ships not to go and get lost. Everybody begin to see how math is invented sometimes? But then we teach you math in class and we just tell you, sit down, here's some logarithms. How is that fair to you guys? And again, I feel like I'm a lawyer for your generation. I'm trying to defend you guys in the court of law of math education. We need to do better. Educators need to do better. We got to get more kids doing math for fun. Number 5, you need to know how to use a formula for anything. I was helping a kid. Oh man, I needed to pray for mercy and patience because the kid his homework was using formulas to find the volume and surface area. I'm like, okay, so do you know how to do the problems? He's like, I think I'm a little confused. I'm like, well, here's the formula, plug in the values, right? And then the next time I see the kid, like, have you done the problems? Well, I think it's just a little bit confusing. I'm like, have you tried? Like, you see what I'm saying? And again, I need to be patient, but I think I'm just getting old, okay? But anyways, my point is this, though. Sometimes you just gotta try. It's not even about whether or not you can do a concept. It's how are you showing up to the game? That's the problem. The math battle, a lot of it is how are you showing up? Does that make sense? Some people don't even show up. They're barely awake. I'm saying you need to show up to the class and say, I'm going to dominate in math. That's the first step. And then if you make a mistake, you don't say, well, I'm just not a math person. Oh, it's just not for me. No. You say, what can I do better? Are you guys seeing why this is important? Your mindset is a big part of being good at math. If you have the right mindset, that reminds me of the other guy who was the best in math in my school. I would wake up in the middle of the night in boarding school, and this kid was doing math for hours. He's an engineer today. You ask, how did he go from a guy nobody knew to ranking with this guy who went to MIT as the best in math in the school? Practice and attitude is key. Number 6, solving literal equations. Solving literal equations is when you're solving an equation for a variable and you don't know the numbers. You don't need to know the numbers. Like, what's the volume of a cube? Anybody know? Rectangular prism. What's the formula for the volume? Go ahead, Caleb.
Length times width times height.
Length times width times height. But what if I know the volume of this room? I know the volume, I know the length, I know the width, but I don't know the height. Why would that matter? If I'm trying to paint this room and I need to get the height to then figure out the surface area of how much paint to buy. I've been asking kids recently, and guys, again, I'm with you guys, okay? I might sound a little intense, but I'm just trying to be like a coach saying, we got work to do. I've been talking to some people in your generation, and I'm like, hey, do you know what 10% off means as far as discounts? And some of them are telling me they don't know. Okay, guys, we got a problem. You know why that's a problem? How are you gonna know if you're getting a deal at a store? Like, he didn't know what 10% off meant. We need to help your generation to kind of ease off the calculators and move back into some mental math and grow in mental math. Does that make sense? When I go to the store, I see, okay, that's a good deal. My mind is 15% or 10%. Unit price, it's pre-algebra all day in the store. You guys know that? But what happens when a generation grows up with just calculators? Then they can't do that. Somebody gave me change at a store a few years ago, and I said, oh no, that's a wrong change. But they just plugged it in, they gave me, I'm like, no, because I could estimate, which is something we should be able to do, to be able to tackle, if you can estimate, you can know when the change is wrong. And the last topic, guys, is graphing and special triangles. Everybody got it? You guys have the keys to get you a solid foundation that we can build on for our conversation. So let's start with the concept. So see, this is pretty cool. We have the board, right? I'm going to write a problem on the board. Give me 1 second. Let me turn this around. Make sure this is okay. Let me double tap.
You got the whiteboard up.
You know what? I think it's showing up on there. Or how do I make it so it's here, if you don't mind? So we're going to do one quick question. So everybody on your piece of paper, take 72. Can everybody write 72? Sorry. 72. I think it was like the advanced here. Take 72. Can you prime factorize 72, please? What is 72 over 96? Can you prime factorize 72 and prime factorize 96? How do you prime factorize 72? You break 72 down, you divide it by 2, and you keep going until you only have prime numbers. So can you write 72 over 96 and please prime factorize each of the numbers? Let me see if I have another pen. If anybody has an extra pen, I want to hand it to someone here. So 72 over 96. I've been doing math a long time in my life, but you know how I would have done that problem just a few years ago? I would divide both the 72 and 96, by 2 and by 2. Does anyone know what I mean? Like you take the 72 divided by 2, 96 divided by 2. And guess what I realized? Why don't you just prime factorize both of them and then just cancel what they have in common? Everybody see where I'm going with this? Mm-hmm. That method is going to help you a lot. Just prime factorize both and just like cut out what they have in common. So now what would be our final answer of 72 over 96? And those on the call, feel free to put it in the chat. Those on the Zoom call. Let me see. So 72 over 96. You got an extra pen by chance?
You have an extra pen? Edward doesn't have a pen. Okay.
You know what? Next time I travel, I'm gonna start traveling with 10 pens in my pockets. I used to do that. No, that's fine. I used to do that. I'm sorry, my bad. So prime factorization will help you simplify the fractions. While we do that, can I ask you guys to write a couple of things out on your paper, please, and those watching too? Number one, can you guys write down what is the slope-intercept form of the equation of a line? If you know that, can you write that on your paper? We're going to come back to that. I'm just going to highlight a few formulas you need to know. The slope-intercept form. If you don't know what it is, just say slope-intercept. Just say slope-intercept. We'll come back to it. So you need to know the slope-intercept form. And then, of course, we talked about prime factorization. Perfect. Thank you so much. So I'm going to do the prime factorization problem on here. So let's see, 72 over 96. Okay, so 72 over 96, for this one, you take the 72, and most people use what's called, and it's showing up there too, they use what's called a factor tree. So you take it and you break it down, right? So before you can even do prime factorization, you need to know what a prime number is. Could we just list a few prime numbers if you don't mind? So give me a second, I'm going to start from the first one. So what is the first prime number? This is actually a very important question. What is the first prime number?
2.
2. Why didn't we say 1? Okay, 1 only divides by itself. Who came up with the term prime numbers? You have Euclid, right? So Euclid of Alexandria. Where is Alexandria? The reason why this is, I think, is important is that A lot of students don't realize the math history and the universality of mathematics. You can be an exceptional mathematician. You can become very good at math. Everybody hear what I'm saying? And unfortunately, I think that the question becomes, we've not given you enough people to look up to in the math field, and so you're not necessarily looking at the human reality of mathematics. Sorry, Mr. Silas, it says 3. This touched it. I hope I didn't change the channel.
Oh, you're fine.
Okay, perfect. So, so the first prime number is 2. Euclid gave Euclid's book called The Elements of Geometry, which if you want, I have it in my website. I'll send to you. It's a free book. You could read it. It'll get your mind on another level, right? That was like literally what they used to read back in the day was just that book. What's the next prime number after 2?
3.
What's the next one? Next.
7.
Next.
11.
11. Next.
13.
Next.
17.
Next.
19.
Next.
23.
Next.
29.
Next.
31.
Next.
37.
Next.
43.
Before 43. Okay, next.
43.
Next.
47.
Okay, isn't that's I'm gonna stop there. Guys, there's an infinite number of primes. The reason why your credit card works is because of prime numbers. The reason why network security works is because of prime numbers. We use prime numbers to encrypt. Why? Because when you have a big number, if the criminals want to try and break that number down to find the prime factors before they steal from you, it sometimes could take them 10,000 years, so they can't. Who came up with prime numbers? 2,300 years ago? Some random guy from Greece? And that's what powers our technology today? It's not crazy. What will you and I come up with? Think of yourself as someone who's going to add value to the society you live in, not just someone who's going to be a consumer. Can you imagine what Euclid would have done if he had the internet? Now, some of you are like, oh, Mr. Amos, calm down. Here's why I'm trying to be pretty intense right now. Your generation has a chance of a lifetime with the revolution on the AI revolution happening. And some of you are probably wondering, I'm not sure when I want to do this and that. What? Go do some research, dig in, get ahead. Does that make sense? This is your time. This is your time. Don't be sleeping right now. This is not the time to sleep. Those who sleep in the next 5-10 years will literally be in trouble. You don't sleep right now. You literally find direction and you go. Everybody said, you go. Why? Because so many people are confused on what's going on. You could be like, oh, I know where I'm going. You go. And you support your family. And guys, what I'm trying to get at is you are living through a revolution. Everybody get that? Take advantage of it. Don't waste it. Don't waste it. Why am I being like intense? Here's why. Because at the same time, your generation has more distractions than any other generation. It is crazy how many distractions some of my generation gave yours. And I'm sorry again on that note. Please don't allow the distractions derail you. If you're 16 to 18 years old and a year from now, you're not earning some sort of money on your own because of building applications, there's a problem. Why am I saying this? Because the barrier to entry for business has gone to the floor. I can launch a website, start collecting money, and build a product before I get off this call in 30 minutes. And I mean what I just said. How? Because there's agentic AI. What are we doing with it? Right? What is your generation doing with it? Why aren't you taking your skills, finding a way to help people with it, and then people pay you for the value you bring if you're 18 years old? Are you seeing my point? I couldn't do that when I was 18. I couldn't. Guys, you can spin off, funny story. Today, there's a website called Replit. They didn't pay me to say this. They're giving their agentic AI for free for the whole day. Guess what that means? You can build a website of any kind and any app today for free. They are celebrating 10 years anniversary. Isn't that crazy? It used to take us 6 months to build a website. Now you can literally tell Replit, build me a website to show my friends how to find a career for their lives and make it with navy blue and royal blue and deploy the website and make it so that Stripe can collect money from the website for those who want to pay for my consulting. I'm just giving you an example. Done! 5 minutes, you got a website. Guys, we could do this, okay? I brought up Euclid because prime factorization is key. Okay, let Amos do a few more problems here. So, we've talked about breaking numbers down, right? If you have 28 over 36, prime factorize the numbers, right? And the reason why this is better is because you can cancel like that. But here's what I'm going to give you guys. I'm going to give you guys a treat. Are you ready for this? I'm going to connect pre-algebra to algebra in one snapshot. Watch. You have x squared plus 8x plus 7 divided by x squared plus 9x plus 8. Guys, look at this. This is x plus 7, x plus 1, and this is x plus 8, x plus 1. You cancel. We just use the same logic from pre-algebra of canceling common factors in algebra of canceling common factors. Do you see why we can't let kids do algebra if they don't know fractions? Because they're in trouble. You need to know fractions in order to do algebra. Because the method of reasoning is the same of how you're operating with the problem. Does that make sense? It's like a mental representation. Guys, you know when you go to work out, you gotta lift those weights? I need you doing math every day. Lift those weights. Everybody get that? Every day. Give me more. Give me more. Until I get a perfect score. That's your bare minimum. You aim for it. And then if you get a 35, you've tried your best, you come to Mr. Silas and say, Mr. Silas, I tried for hours. I just made a 35, but I've done my best. That's what matters. You did your best. But if you're like practicing 1 hour a week and you're like, I got a 27, I'm going to be okay there. Why? This can change your life. This can change your children's life, right? And I know Mr. Silas has emphasized that. But again, I'm speaking to your generation, not just you guys. Some of you are like, man, he came like he's mad at me. No, I'm not mad at you, okay? My blood boils when your generation is not reaching its potential. That's what makes my blood boil. And I'm watching the distractions we've given you, and we got to change it. Okay, let's look at the next concept. So we're going to look at the next math concept. I don't know if this will let me switch to the next slide. So we've looked at prime factorization. Any questions on prime factorization? You break numbers down, it's great. Okay, the next thing we're going to do, and then you can decipher some of the chat. I know somebody has a chat, which looks interesting. I'll come back to that as a question. So I know somebody has to leave here shortly. Can you give me 7 minutes? And I'm just going to go boom, 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 boom for 7 minutes. Is that okay? Okay, I'm going to go for 7 minutes. Is it still broadcasted? Okay, it is. Wow, look at that. Look at technology, guys. This is crazy. I can look at 2 screens at once. Okay, so now we have prime factorization. We've covered that. Factoring polynomials. Okay, when you have x squared plus 4x plus 3, the number in front of x squared is a, the number in front of x is b, the number by itself is c. So basically the idea is that I'm looking for 2 numbers that multiply, right? In this case, whenever you have x squared by itself. So first of all, guys, let me just give you a quick note. This is recorded, okay? So I'm sorry, I'm just about to kind of rap for 5 minutes, but I'm going to pause, okay? So the number in front of x squared is 1. So we don't have to write 1, but we know it's there. The number in front, this number is 3, right? So what is 1 times 3? It's 3. So the 2 numbers multiply to give you 3, and they add to give you 4. So you need 2 numbers that can satisfy that condition. And those 2 numbers are 3 and 1. Because a is 1, okay, then you literally just write x plus 3, x plus 1. This is important, guys, because this right here is a whole lesson in an algebra class. What I just told you, they teach that as 1 day of the class. When a is 1 and you find the 2 numbers that multiply to give 3 and add to give 4, just plug in the 2 values. But what happens when it becomes 3x squared plus 7x plus 5? Something like that, right? Now you can't just do that. So a is not 1. Now, in this particular case, I just made up those numbers. They might not factor out nicely, but what is a formula that I can always use? Quadratic formula, right? Minus b plus or minus square root of b squared minus 4ac over 2a. And I take those values and I plug them in. Well, this is going to allow me to teach you how to use a formula. How do you use a formula? Take the values. A is 3, b is 7, c is 5, and plug them right in, right? This is 7. So you have, I'm going to write 7 minus 7 plus or minus square root of 7 squared minus 4 times 3 times 5. And you divide that over 2a. Guys, this is important. We're not trying to trick you in math. We literally mean it when we say plug in the formula. Like, you plug it in. The rest of this requires you to know integer arithmetic, right? This requires you to know radicals, right? But why am I listing those topics? I'm trying to teach you how to think like a mathematician. When you see a problem, guess what you need to ask? What tools do I need? So what tools do I need? I need integer arithmetic and I know radicals. What happens if I say, I don't know what to do next? Guess what Mr. Amos is going to say? Go back and review those 2. Do you see how you learn? Go review those 2. But in this case, you have negative 7 plus or minus 49 minus, what's 12 times 5? 60 divided by 6. Well, guess what? You have minus 7 plus or minus square root of negative what? 11, right? Now you got complex numbers, which is what powers cell phones. Did you know that's how your cell phones work, your smartphones? Because of negative numbers in the square root. Complex analysis. We don't tell you that. It's not fair. We need to. But anyways, the point here is, guess what would have happened if I tried to factor that polynomial earlier on? I would have been hitting my head going, what two numbers multiply? Because there's no real solution. Right? It's a complex solution. Okay, let me give you a quick rule here with fractions. You can write this like this. Does everybody know that? Yeah. That will help you sometimes. You split it into two. While we're on this topic and we're still here, here's what I'm going to do. I want to talk to you briefly about the radical side. What happens when I have square root of 28? I need to know that that is 2 times 2 times 7. What topic did I use to do that? Prime factorization. If you leave here today and you heard one thing, what is it? Prime factorization. It showed up again, right? So now I want you, when you meet your friends, you guys giving handshakes, guess what you do? Prime factorize 40, bro. That's the new thing, right? Yeah, everybody just prime factorize it every day. So when you break it down, you take out these 2, you get 2 squared of 7. Guys, we just went from polynomials to quadratics to radicals. We can just, math is like, I mean, when you're playing basketball and you got to make a basket, isn't it helpful if you have a few options in your hands? I can make a layup, I can make a 3, that's what you want with math. Have all the tools and know which one to pick when. Does that make sense? Some people only have one tool. And anytime I'm tutoring and the student tells me, oh, my teacher says I have to do it this way. Oh boy, that's when my blood boils a little bit. Why? Because why is it only one way? What if there's a better way? Anyway, sorry. Amos is just like, I'm like in the wilderness crying out here for like, we got to change this stuff, right? And I really hope we can get this movement going. More kids doing calculus for fun. Like just doing math for fun. Okay, let's wrap up with one more category. So we've looked at integers. I'm going to scroll down. So I got all the topics for the ACT math, all of them. They're right here. We just literally, I got more problems. We're going to be doing a lot of problems in the second half of the class. But let me pull out one more thing, and then we'll land our plane. And this is called special triangles. Okay, special triangles. Are you guys ready for this? This is Mr. Tarfa's like favorite thing of all time. This is like 1 minute of special triangles. 1 and 2. Everybody see this? This is called a 30, 60, 90 triangle. And this is called a 45, 45, 90 triangle. If you start out with these two shapes, and this one has 1, 1, 1, 1. Everybody see that on the right side? And this one has 2, 2, and 2. What is the sum of angles of a triangle?
360 or 180.
180. Okay, by the way, how many of you recognize this formula that I just wrote? That is called the sum of angles of a polygon. But for a triangle, n is 3. That's why the answer is 180. But what if it's just a square?
It's 360.
360, because you put 4 minus 2 times 180. So this is 90, 90, 90, and 90. Guys, this is going to save you a lot of headache in your trig class if you haven't taken trig. Then the one on the right, let's do that one quickly. I'm going to bisect the angles. Everybody see this here? If I bisect the angles and I extract this shape, I now have a 45, 45, 90 triangle with the sides of 1, 1 and square root of 2. Everybody see that? Yeah. On the left side, if I bisect, I bring it out, I have 60, 90, and 30. And this is 2, this is 1, and this is square root of 3. How did I get the square root of 3 and square root of 2? I used Pythagoras' theorem. But speaking of math history, who's this dude called Pythagoras? He lived 200 years before the dude who did prime numbers. Guys, we gotta change our generation. Look at the names I'm calling. From 2,500 years ago? Where's Caleb's constant at, right? Where's well, I'm trying to remember the name, I'm forgetting, but I'm just saying, where is Mr. Amos constant at? We got work to do. Everybody see that? Why not? Why can't we come up with things that change the world of math or science or whatever?
Oh.
Right?
You forgot to start sharing this when you're right.
Oh, which one? Sorry.
This one. What's this?
Sorry, we're just going to show them the screen there.
Yeah, they were like, "Are you writing? You was cooking too, bro." They missed the show. That's why you come in person.
I'm so sorry, guys. Yeah. I'll share you the recording option.
Yeah, because you can't repeat it. It was too great.
So
right, there you go.
There's it. So sorry, guys, on the call. You guys matter just as much as those here, but I'm so sorry I missed that. So this is the special triangle. So let me land with this. Pythagoras' theorem is the backbone for a lot of things you're going to do in math, right? A squared plus b squared is equal to c squared. But Pythagoras' theorem, some people call it the Pythagorean theorem. They're both right. So I don't want you guys fighting out there about, hey, it's Pythagoras, Pythagorean. At least it'd be good you guys are fighting about what matters, right? I'm kidding. But wouldn't that be funny? Two kids on the playground fighting? It's Pythagoras, it's Pythagorean, right? It's better than fighting about who's the best breakdancer, right? Anyways, the point I'm trying to make, though, is that you want to make sure you know Pythagoras' theorem and use it with special triangles. Guys, I promise you, go home tonight and watch a video on special triangles if you have not mastered it. Which leads me to one thing, and then I'm going to land my plane. I know one of our students needs to step out, and then we're just going to stretch for like 2 minutes, and then we're just going to do a lot more math and wrap up. Guys, do you know what it means to master something? When you ask me my name, do I even think before I answer? If you ask me to prime factorize a number, should I think before I answer? That's the level of confidence you need to have. Math is not a guessing game. Math is the subject of specificity and exactness. And there's some uncertainties that come up here and there, but the point is, it's specific. What I mean by uncertainties is once you start getting into PhD level math, not all the questions are answered. You guys know that, right? But I'll end with one more story of why your generation is in a weird spot. A few years ago, November of 2022, this random chatbot thing, ChatGPT comes out. Everybody's like, oh, this is crazy, it can do this and that. But it couldn't do some types of basic math. AI doesn't grow, abilities don't grow in the same way human beings grow. Because guess what happened in 3 years? PhD level mathematicians are now being corrected by AI. Guys, I'm talking of the best mathematician in the world uses AI to bounce and check some of his work. You got a mathematician in your pocket, essentially, of a kind, and you're telling me you can't push it forward in math in your life? Come on, right? You see, my point is, that's just a tool, though, because guess what some people are going to use it for? They're going to use it to cheat. You don't need to be doing that. You got to be thinking of how can I be better. So everybody get that? Special triangles tonight. Make sure you, internalize it. You get me? Special triangles, and then Pythagoras' theorem. Make sure you know those things well. We're going to keep building on this, okay? But today, and this first segment, I'm going to end here. Once you know how to derive the special triangles, like we did with the 30, 60, 90, where you take an equilateral triangle, break it down, and create this 30, 60, 90 triangle, here's where it gets fun. And we can stop here. 1:3:2, 30, 60, 90. If I give you a shape, and I don't tell you anything, and I just say this is like 12, and you don't know what this is, but you know this is at 30 degrees, guess what? You know that's 6. You do, because you have the ratio and proportion, which is the last topic in pre-algebra that some kids struggle with, and we still put them in algebra. Bad idea. You need to know ratios and proportions, right there. Ratios and proportions. Everybody see that? Yeah. Because out of ratios and proportions, you get unit price. When you go to the store, how do you know you're getting a deal if there's 12 items in the box? Unit price. You need to know ratios and proportion because of chemistry. Why? Because math and chemistry are they're like buddies. What is the twin for math? Physics. You need to know ratios and proportions for physics. Are you guys, one thing I want to leave you with, okay, because I know there's a lot I've shared with you today, but one thing I want to leave you with is this. Every math topic has prerequisites underneath it. Prerequisites, okay? Prerequisites. Every math topic. So this is a topic, always ask this question. What do I need to know in order to do this thing well? Everybody get that? And here's why that matters more than ever before, and then I'll let us pause. Guys, you can be the best in AI on Monday, but Friday, you fall behind. Why? Because a new tool just showed up. And now you got to learn the new tool. Your generation is literally living through we're moving. Oh, okay, what's new again? Guess who's going to win? The person who knows how to take a problem, decompose it, and move forward. And what field of study does that better than almost anything else? Math and physics. Those who know math and physics will kind of run the show for a while. Become one of the best. And help your friends become one of the best. And let's see Chicago as number 1, right? Or number 2, Houston. Let's do both, right? I live in Texas. So, but guys, I know that was a lot. I am so sorry. I have to pause so people can transition. And then can we reconvene in 3 minutes? But before we do that, is there any quick question for 1 minute before we're going to reconvene in 4 minutes? Any questions that you just want to say? I have a quick question.
Brother Caleb said, forget that game, man. We doing math.
Okay. So at least let me give you guys 3 minutes. So everybody on the call, if you don't mind, let's take 3 minutes. Send me your chat. I promise I have all the topics. It's just I also wanted to inspire the kids. I don't want to just do problems. I also want to change your mindset. Because once your mindset is changed, guess what's going to happen? I give you the content and guess what you're going to do? You're going to take off. But you got to make sure your attitude is right on. You can do this, and we're going to push for that 36. 4-minute break. We'll see you guys in 4 minutes.
Caleb, come sit here.
Alright, anybody have any dietary restrictions?
Nice to meet you. You take care. Let's keep in touch. My email is amosthemathguy@gmail.com, by the way. So it's amosthemathguy@gmail.com.
Hot dogs or ribs. Alright, so I'm getting some shit. Just so you know. Alright, so.
Mr. Simon, where's the bathroom?
Right here.